So let's look at savings annuities. So the idea here is that instead of just putting one amount into an account and letting it accrue over the years, we're going to make regular deposits into an account in order to save up. So, maybe I decide that I want a vacation fund and I'm going to put $200 in my account, in my savings account, and earn money by doing that, both getting some interest and also putting in my own money so that in 2 years I can take a big vacation. All right, so that's the idea of a savings annuity. All right, so notice how this is different than compound interest problems that we did in the last video, because instead of just making one big payment into an account, we're making regular deposits into that savings account. All right, so our formula is really ugly looking, and we'll take it a piece at a time as we work through one of these. But let's notice that P sub n is our future value. It's the balance that we're going to have in the account after we save up for whatever number of years we plan to save up for. And then D here is the regular deposit that we're going to put in every year, every month, every week, depending on how often we decide to do this. And it's going to be regular. And then R is our interest rate, as it always is, in decimal form. And K is the number of times we are compounding. All right, so let's plug in, or let's do an example, and we'll plug into this huge formula. So let's notice, number one, you deposit $200 each month into an account earning 3% interest compounded monthly. Now immediately, because we are depositing every month, it's not a compound interest problem, it's a savings annuity because it's a regular deposit. So our first question is, how much will we have in this account in 30 years? So maybe we're saving up for a child's education here. Or 30 years is a long time though. Maybe we're just saving up for retirement. All right, so let's fill in. We don't know P sub n. That's our future value that we want to know. All right, but I'm going to grab... Okay, so I've kind of got this fraction form here. Okay, so D is next. D is our deposit amount, and that's $200. And let's notice there are two parentheses, so we want them both there. And then our formula calls for 1 plus R over K. 1 plus R is our interest rate, 0.03, expressed as a decimal, over K. K is... we're compounding monthly, so that's 12 times per year. And then I want to raise that to the NK, and actually I might have to kind of cheat a little bit. Yeah, probably. So our N times K in this case, N is the years, that's 30. K is compounded monthly, so that's 12. So we've got 30 times 12 in our exponent. And then we want to subtract 1 and close our parentheses, just like the formula. Now on the bottom, we have R over K, which is really 0.03 over 12. All right, now we've got to work through this ugly, nasty formula. So let's do it a step at a time. Let's notice, first of all, on that huge top, we have a little set of parentheses within the bigger set of parentheses. So we need to do that first. So, in fact, I'm going to do my draw so I don't have to keep going to this equation feature. So I'm going to have 200 first set of parentheses. Let's, in our calculator, put 1 plus 0.03 divided by 12. And if I do that, 1 plus 0.03 divided by 12, it's going to end up being 1.0025. So I have 1 0.0025. And now I also want to put 30 times 12 into my calculator. So 30 times 12 is 360. So I have raised to the 360 power. And then I have this minus 1 all over. Now, I can put 0.0312 into my calculator, but the truth is back here I had it and I added it to 1. It's really this decimal part right here, 0.0025. So the bottom is 0.0025. Now let's keep working through this thing. And I'm actually going to give myself a little more room. Alright, so I need to now do the exponent here on the inside of these bigger parentheses. I need to do 1.0025 raised to the 360 power. So I still have my 200 outside, but I'm going to do my 1.0025 to the 360 power in my calculator. And I end up getting, taking it out all decimal places, 2.4568 42212. So keeping all the decimals. And then I still have my minus 1 here. All of that over 0.0025. Now let's finish the inside of these parentheses. So I'll have 200 times 1.4568 when I subtract 1 from that first number. 4, 2, 2, 1, 2. So I just did this minus this. Now let's finish off the top. So I'll do the 200 times the 1.4568 blah blah blah. That gives me 291.368 4423. Divided by the bottom. Now, be sure to keep all these decimal places that I keep in the problem. Otherwise, you'll enter something into my open math and it will be wrong, because it really does make a difference if you round your decimals too early. Alright, so now that I'm at the final division of the top divided by the bottom, I'll go ahead and I'll write out, I'll go ahead and round to cents. So we have $116,547. That is a 47, not a 97, and 38 cents. So after 30 years, our $200 deposit has earned quite a nice little amount for us, which kind of shows how retirement works when you're adding to an account for 30 years. And usually it's more than $200 a month and your employer is adding to something. This ends up being more like $300,000 in 30 years. Alright, so let's look at B. How much total money will you put into the account? Alright, so we're looking now at how much we put in. There's interest in there, so let's just think of it this way. For 30 years, we've been putting $200 into this account every single month. So let's take $200 multiply it times 12 times a year times 30 years. And that will tell us how much we actually put into this account. So let's see, 200 times 12 times 30 ends up being $72,000 that we put in. That means the rest has to be interest that we've earned. All right, so to get how much total interest we earned, well, let's take what we actually got after 30 years, subtract out what we put in, and that's going to account for leftover interest. So $116,547.38 minus the $72,000 that we put in. And I'll stick that into the calculator. And the interest we earned was $44,547.38.